maybe I won't get quite a saturated peak, so I'm going to wipe the one plate off so there's a little less material in there. Sometimes it's a little thick, depending on whether the plates actually fit tightly together or not. So let's stick that back in and see if maybe a thinner film doesn't give quite as saturated of a spectrum. So we'll collect sample again. The background age is only a few minutes. A-2, since it's the second spectrum. Well, it may look about the same. It's usable. That's better, right? We're not pegging, we're not down there at the 0% transmittance. Got a nice thin layer. And we see that nice sawtooth pattern here, indicative of a monosubstituted benzene, and we know we have a monosubstituted benzene. So let's save that. Set file name to title. It's a better looking spectrum. So I'm done with this. I can put a label on there and store it. And that's relatively non-volatile material, so it can just be stored in my basket. A, and we will tomorrow purify that by column chromatography. And you can hear that. That means I forgot and I let it go all the way dry. But that's okay. Stick that label on there, and we'll just store that down here for later use. These need to be cleaned with some hexane. Can't clean them with acetone because acetone is usually wet. So the best way to clean those is just to put a little hexane on a nice, fresh, clean Kim wipe. And then rub the plate on there to remove any residue. And since I can't remember which side I used, I'll rub both sides. And we'll do the same for the other plate. So now there's two plates in there, one broken and thin. These guys back. I'm going to go ahead and clean the spatula or the stir rod the same way, since it had nothing on it except that compound. Just give it a little rinse with some hexane. Put it away. And we'll have a look at that IR, do some searching, some functional group interpretation. And then I'll turn off the camera and I'll clean up. You don't have to watch me clean up. I'm not going to run the TLC tonight because I have a letter of recommendation I got to finish. It's due today. So we're looking at our IR, and I think you can see that the peak we want is there, but there's also some peaks we don't want. So these two peaks down here you should be able to identify. And these two peaks here, that one and that one, that's diagnostic. We got this one here, that's a diagnostic peak. This one here, And all of this you should be able to determine. I'm not sure what that is. And then, like I said, this sawtooth pattern here, that's typical of a monosubstitute benzene. Baseline's actually pretty good. This down here, that's sodium chloride, because sodium chloride absorbs between 400 and 600, so that's not real. But it's almost not worth correcting this baseline. It's pretty solid, so I'm not going to bother. Right, we got between about 10 and 60% transmittance, which is nice. So I can move this, get it out of the way. So let's find some peaks. And I know I want that one, so I'm going to find everything that's shorter. Actually, I know I want that one too. It's 1600, 1492 and 1600. Those are diagnostic. That's good. We'll replace this guy. And then, as usual, I can pull those peaks around so that I have them in nice locations. This time I didn't have to mess with the display limits. That 1706 peak we were kind of hoping is gone, but it's not gone. Oop, that was a mistake. So not all of these peaks are significant, but at 1445 you should be able to identify, and at 1376 you should know what those are. These guys here, these little ones at 1200, probably don't matter much. That peak's not real. I'm going to delete it. This peak here, it's 581. That's not real, that's sodium chloride. Same with this 632. And the peak at 738, we don't care. But the peak at 701 and the peak at 755, those are diagnostic. You should be able to figure out why those are there. There we go. Some of these in here. This 1033 probably doesn't matter. And get rid of it. So that looks nice. Let's save that. And now we will do a library setup. We got the Georgia State Crime Lab and the Nicolay Condensed Phase Academic Sampler. That's fine. Let's search and see what it says. 58.98% match isn't very good. For triphenylmethane, 97%. Meh, at least as a phenyl group. Nothing else is very good. So we don't have any decent matches. And if we looked at the search expert, he would tell us that it's not any good matches. I'll go ahead and print that. We'll OK that. Oops. Call that Grignard search results. And I'll be posting this up so you can see it. I'm going to print this one. Doing our product. And we'll do the IR spectral interpretation. It thinks it's an aliphatic carboxylic acid. Monosubstitute aromatic hydrocarbon, that's good. Aliphatic hydrocarbons, well, we do have our ring. So that's going to help you a little bit. It's not identifying this big peak, and it thinks that it's carboxylic acid, but there's really nothing there in that region where the carboxylic acid would be. So this is a little bit misleading, but we'll go ahead and print it anyway. And we'll call it Grignard functional groups. So you can see that the monosubstituted benzene, alright, here's peaks that are due to monosubstituted benzene, these two, and those two down there. And the aliphatic hydrocarbons, obviously we have our standard kind of peaks that we always see for that. With the carboxylic acid, there should be a big broad peak in here. There's not. There is this peak, which unfortunately shouldn't be there, but it's not clearly diagnostic for that. So I don't know why it thinks it's carboxylic acid. Save my changes. Close that. Actually, I'm going to close Omnic. We don't need Omnic. And I can put this computer to sleep. Just make sure I took the sample out. I did. So that's it. We've run the Grignard reaction, and it is ready for purification tomorrow by column chromatography.